Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1203. And okay, all right. Nice to see you. Good. Everyone looking good. A little less energetic. The first week of school already grinding you guys down, huh? It's okay. You'll get used to it. All right. Let's continue. So let's jump right into it. I mean, yep. All right. And I assume you guys saw these problems here. Typing on a screen is very weird. Okay. For this class, hopefully you guys got into your groups okay, and you actually attempted this. But the first order of business is to actually work through this a little. How many groups is in this class? I sent an email. I sent emails. I think there were 4. So many emails this weekend, I'm not sure where I. Okay, so there's a group with no L in it. That's 1. And there's a group with Madeline. That's 2. And there's a group with Luke. I have no idea if these people are here because I think some people are missing. And it was 3. I think it was 3 groups. Okay, so these are your groups for at least until the midterm. So we have Noel, Sarah, and Bridget in one group. And Madeline, Yinghui, Amanda. And there's just an email here, but I don't see the name. Some of the last name of Zhang in another group. And there is Luke, Anya, and Caroline in the last group. 2 groups of 3, 1 group of 4. Yeah, that sounds correct. I think we have about 10 people in this class. Very small, intimate gathering. Okay, yeah, all right. So maybe what I will do is I will just ask ahead of time for what do you guys think the answers are? Make it a little bit of fun. Not exactly best. Okay, group one, who I don't even remember who was mentioned there. What did you guys think this answer was? Noel's group. Noel, Sarah, Bridget.
1/2.
What? Yeah.
Oh, you thought this was 1/2? Okay. Did you guys actually work on this together?
No, we didn't. I only heard from. I didn't hear from the other two. I'd sent out an email, so.
Okay. All right. What about the second one? Hopefully you guys will get that set up today.
Is it 3?
You think the answer is 3? Okay. And this one? Someone else in that group? Noel or Bridget? Did anyone do that one? No? Oh. I don't know if any other group did that one. Let's see. Did you guys get something here? To expand this? Okay. Group 2. Guesses here. I mean, we're going to work through all of them, but I just wanted to see if you guys had any ideas in the first place. It's like Madeline's group. Madeline, Ying Hui, Amanda. Guesses for this one? Combine the logarithms.
I said y to the x squared minus 5.
Y raised
X squared minus 5.
are you looking this one here?
Oh, I'm sorry.
Because there's no y there.
I'm sorry. It's a log base 2 and parenthesis x to the fourth power times x over x cubed.
Is that your final answer?
Yeah, I didn't simplify.
Can simplify. Maybe next time I'll say combine and simplify. It's probably my fault. Okay. E to the x equals 12. What did we think the answer was? Ln of x equals 9. Okay, what about this one? Okay, group 3. Do you have any guesses here? Are there a lot of people from group 3? Luke, Anya, Caroline? No? Okay, so I guess this is open to anyone. Were there any guesses here from anyone from any group? No? So everyone? What about any guesses here?
Wait, can I give a guess for number 2?
Sure.
Could it be like 1/2 ln times parenthesis x squared minus 1 minus 1/2 ln x times x plus 3 cubed.
Oh, Madeline just came in. I was calling out Madeline and she wasn't even in the room. Okay. And do you have any guesses for down here for number 4? Well, the quiz must have been fun, huh? Well, I mean, for the quiz, how many log questions did I ask? Maybe around 4 out of, I think there were 14 problems on the quiz or something like that. Maybe like 4 or 5 of them were logarithms. Maybe you got a few, but hopefully it went well. But let's, okay, so we have some guesses and we'll just see how those go. So what we're gonna do now is we're gonna write out, we're gonna actually do these, okay? We shall do them together and just see where we are. And in fact, I probably want to make this slightly bigger. It's like a nice size. And there's like a much on my screen here. It's trying to be crazy. Okay, so let's get started. Hopefully we're all awake now. Okay. Okay, so e to the minus ln2. Let's see. Now, as you'll see for a lot of these, there are multiple ways to get through to the answer, multiple ways to skin a cat here. And so I might show a few of them. If you tried a different way that I didn't show and you're not exactly sure whether or not you're doing the right thing, I guess you could actually just point that out. So let's actually go. So here we have e to the minus ln2. Couple ways to do this. One, we could, using a law of exponents, realize that this is that, right? Then, using the fact that we know a to the ln a of x is just x, your e and your ln will cancel because they're right beside each other. And so that would just give you 2 to the minus 1, which is half. Okay, and that was a guess. So awesome. Right, but there were tons of ways that we could do this as well. Or you could do something like use a log rule instead of an exponential rule first. And the log rule says you can take that -1 and you can bring it up as the power of the thing being logged. Now you can use that rule, a to the ln of a equals of x equals x. So those will cancel. Because exponentials cancel logarithms, logarithms cancel exponentials. We learned that last time. So again, you get 2 to the minus 1, get minus a half. So yeah, lots of ways you can do this. You could first do e to the minus ln2. You could realize that, oh, it's a negative power, so I can move it under and put 1 over. Then I can cancel those, and I would end up with 1 over 2 anyway. Tons of ways to do it. All of these ways are correct. So yeah, it just means make sure that you're applying the correct rules at the correct time. I'll tell you a common mistake for a problem like this. Some students get the idea that things like e's and ln's would cancel, 2's and log to the base 2's will cancel, etc. But they don't actually apply that knowledge correctly. So for example, let's leave it in red so we know that we don't do it. You had e to the minus ln2. Some people might decide, oh, I can cancel the e's and the ln's, and then I would be left with just -2. Right? So that's a common mistake that I see all the time, and that is actually incorrect. And why is it incorrect? Yeah?
Because the negative sign is in the exponent. If the negative sign was in front of the e, then it would be -2. But
Right. So it actually matters. So you have to remember what rule you're looking at to apply. So the rule says a to the ln of a of x equals x. Equivalently, if your a is e specifically, this also means e to the ln of x is x. But what you have to realize is that there is nothing in front of the ln in the rules. So this is one of those things where you kind of know the concept, but you don't know the rules exactly. And so, yeah, I kind of know that these things cancel, but you're not paying attention to exactly how they cancel. The rules that I gave you last time, laws of exponentials, laws of exponents, all that stuff, you really want to think of them as your templates. You should be able to fit that rule right on top of the problem that you're looking at, and nothing should be out of place. There should be a position for everything on the page, right? The moment something is out of place, there's a negative sign where there shouldn't be one. There's a 5 when there's nothing in your formula that says a letter should be here or a number should be here. Then you cannot apply the rules as written. You have to rewrite them first. So when I was here, I couldn't immediately cancel the e and the ln because the negative sign was in front. Now, there are various ways that you can get rid of this. One, you can apply the laws of exponents as I did in the first case, or you can apply the laws of logarithms as I did in the second case, or you can apply another rule of exponents that takes the reciprocal in the third case. But either way, what all of these have in common, I had to deal with the fact that there was a negative in front of the ln2 first before applying the rule, right? So sometimes, and this is why your algebra is important, you have to actually manipulate things before you can apply rules and concepts that we're going to be learning. So it's very actually important that your algebra skills has to be on par to actually, oh yeah, I know I want to apply this rule, but this is in the way. How do I use algebra to get it out of the way, right? And that's and hopefully by the end of it you get to the right answer. So hopefully there are no questions there. A lot of you, I think you guys have the right guess for those as well. So next guess was 3. Let's actually see if that was 3. So I have e to the ln of e to the 3. So I can cancel this because there's nothing in front of the ln, so I have e to the ln 3. And I can cancel this because there's a rule that says log to the base a of a to the x is just equal to x. So that is 3. I could have done something else as long as it's legal. I could have first cancel this stuff in here, and that would have given me e to the ln of 3. And then I can cancel this stuff right here, and then that would just give me 3. I would again get 3. Tons of ways you can do this. You can e to the ln of 3. I could have canceled. I already did that method. I could have e to the 3. Could have done this. Then I would end up with ln of e to the 3. Then I could have taken the 3, move it out in front, and then I would have 3 ln e. And then you should recognize that ln of e is 1. And so that will give you 3. And this is because log to the base a of a is 1 for happens here. And why is that? Because you can imagine that there's a 1 up here instead of the x. So if you take a log to the same base, so you have log to the base 2 of 2, well, that's just 1. Log to the base 7 of 7, well, that's 1. Log to the base e of e, well, that's 1. But this is equivalent to me writing ln of e. So you can know that ln of e is 1, etc. So there are tons of ways you can get to 3. Choose your favorite way. No way is inherently better than the other. It just matters what you see first and which rule jumps out at you when you look at the problem. You might see, like in the first example, the last method I chose had a few less lines, but I wouldn't really worry about it. I don't want you sitting in a test going, what's the shortest way to do this problem? No, the moment you see something, just do it. Like by the time you want to pick all the possible ways you could do it and do the best one, you would have finished the problem if you had just chosen at random in the first place. So I just want to show that there are many ways to do it, but none is necessarily better than the other. Now here's this one. We didn't have a lot of guesses here, but maybe I have some guesses now based on what you've seen me doing.
I'm gonna throw out x squared minus 5y.
Yeah, x squared minus 5y.
Oh wait, no,
is
no,
the
no.
guess?
X squared over all over 5y.
Okay, tell me your process.
So I canceled e to the e with the ln. Or well, I brought down like that whole like exponent. I don't know if I did this right.
I mean, just
Never
tell me
mind.
what you're doing.
I don't know.
No, tell me what you're doing. What
I
did you
canceled
think?
like the e with it, with
Like
the
here?
like yeah. But I had.
And then what were you left over with?
X squared minus 5 ln y. But then I just thought of like the rule where it's like ln x like minus another ln something, like the log rule where it's like that's division. So you could like pull the ln. So I realized I don't want to cancel the e to the ln, so I don't know how to get to like the second step now.
Right, but why? So yeah, canceling the e's and the ln here is wrong, but can you see why? What's the problem? Why wasn't I allowed to do this?
I'm not sure.
Yeah, so, okay. So what is the rule you're trying to apply? Maybe you can tell me the rule that you're thinking of, the one that actually cancels?
I'm thinking of like the a to the log.
Yeah, a to the log to the base a of x, right? You know that cancels and gives you x.
Yeah.
Right? Now, look at this and that. Do they look exactly the same? Like what would take on the role of a? Well, the e, right?
Mm-hmm.
And what would take on the role of the ln? Well, the log to the base a, right? And then what would take on the role of the x squared, right?
Yeah.
Which means, what is that? Right? You notice that there's nothing else here. There's no plus anything. There's no minus anything, right? So this is what I mean, like your rules should be like a template, right? When you're thinking of a rule, the rule should fit on top of the thing you're looking at right away. And if it doesn't, then you can't apply it.
Okay.
So that's why you wouldn't do it there, right? Yeah, so that's what I was talking about earlier, and I want to make sure that everyone gets this. So I'd like to know what you're thinking so I can make sure to kind of tweak what you're thinking. So maybe you want to try again. So obviously now you know that this piece hanging off here is a problem. So you want to have a way of dealing with that first. Now, let's actually go with what you thought of first. You remember that there was a rule for logs subtracting each other. What was that rule?
You would like pull the log So it'd be
Yeah, but what is the rule?
it's the, is it called like the division log or something like that? But it's log of a, where was it? I have this written down somewhere.
Yeah.
Log a to log a x minus log a y is equal to log a of x over y.
This is true. Now, of course, you shouldn't have. Is it something like the log division rule? That's that's where you're messing up, right? You need to know exactly what the rule says. You have to memorize it. Okay, so that is the rule. So let's say you wanted to apply that rule here because you saw the subtraction between the ln's. Could we apply it here?
Yes. But just like in the exponents, you could do log of x squared over 5, like e to the log to the ln of x squared over 5, right?
No, you cannot apply it here.
Oh, is it because it's in the exponent?
Why? No. The exponent is not the issue.
Is it?
I mean, compare this to this. Does it fit?
No, because of the 5.
Because of the 5.
So would you
notice that in the
raise
rule,
y?
there's nothing in front of this guy, right?
Yeah.
So you saw this rule and you want to apply it, but you still have to be careful. Can I apply that rule? Then you're going to ask yourself the question, if I take my rule and drop it right on top of the power where I want to use it, is everything in position for me to use it? And the answer is no, the 5 is in the way. Okay, so now that you know that, so you want to use this rule, but the 5 is in the way. Now what?
Can you raise y to the 5th? Because that's it. Like if you
Why? Is there a rule that you're thinking of? What rule is that?
The like log base a of x to the n is equal to n log base a of x.
Right. So if there's something in front of a log and you don't want it there, this is a rule that helps you get rid of it, right? So let's just relabel these guys just for the sake of argument, law 1 and law 2. You saw law 1 first, however, you realize you can't apply it. So now you start to think to yourself, well, why can't I apply that? And it's because you know the rule so well and you know that the positions that things have to be in, you so, oh, the 5 is in the way. How do I get rid of the 5? Then you start to think of this other rule. Okay, there's a rule that allows me to get rid of something in front of a log. So what I would do is I could do that rule first, right? So this says e to the ln of x squared minus ln of y to the 5th. And what I just did now was apply law 2. Now what you're going to realize is that now the power looks like rule 1, right? Because I just have a log of something minus a log of something else. So that allows me to combine both of these into a log, namely x squared over y to the 5th. Okay, so now you're there. Now what? And so this is by that rule.
And now it's the rule of log base a of a is equal to log base a of a to the x is equal to x. So you can cancel e and
well, that rule, you said log to the base a of a to the x is equal to x.
No,
you want the other one, right? Because now you're seeing that it doesn't fit the template, right? So now you just think of the third rule. If I have the big thing down here and a log in the power,
yeah,
then if the base of the logarithm and the exponent is the same, then it just cancels, right? So that goes away. Okay, so that's actually the answer, x squared over y to the 5th. And this, what I just applied was law, well, here I applied law 1, here I applied law 3. applied as in the past tense from the previous step. Okay. So hopefully now you're seeing the relationship between those formulas I asked you to memorize and actually working out a problem, right? So this is the first stage in kind of getting this this math thing under control. You have to have all the rules memorized. You have to have them memorized exactly. Attention to detail is super important because when you're applying a rule, that rule is your template. It has to be fit on top of what you're looking at, right? And this is actually super important for multitudes of reasons. You guys are in science, so I mean, when you're in chemistry, the difference between two molecules could be just like, you know, an OH group or something, and it like has totally different properties just because of that. Like you missing a molecule from something or some group from something can mean a big deal. In the same way, you have to get used to knowing where all the minute positions of things are, right? So that actually gets you to work through certain calculations. And of course, later on in the course, we're going to go even higher with this, where it's now a matter of having some random application that I'm going to use these calculations to figure out the answer to. And that's another level of thinking right there. But you first need to figure out this level of thinking, because if you don't have this level of thinking, even if you have the general idea of how something works, you'll never be able to execute it. You'll never be able to actually go through it in detail and actually get the correct answer, right? Which is important in a lot of cases, right? So it's one thing I just want to get through your heads is that it's not okay to just kind of know this is the rule. No, but you have to know the rule exactly to the point where, like, just in terms of positions on the page where you're, okay, there's something to the top right corner here in my rule, and it isn't to the top right corner here in the thing I'm looking at. What that means is this rule does not apply. I should be looking for something else. Or I should be looking for a rule that can change this thing into that thing, right? That's how it's going to work, right? That's the mechanics of mathematics, right? And a lot of times people will have the higher level thinking down and they'll say, yeah, I get what's going on. I really understand the class, but I do bad on tests because I guess I have test anxiety. No, you don't have test anxiety, usually, right? I mean, like 0.5% of the people who say that sentence actually have test anxiety. Most people, they're doing something mechanically wrong, like what I'm showing you guys here. So it's actually very important for you guys to get this down, right? Otherwise, you'll end up in a situation where like you feel you know everything, but you're doing really bad, you're getting bad results. And then now it's like confusion. I have test anxiety, or Jhevon just hates me and he's trying to downgrade me, or this class is so unfair, or math is so stupid, right? You're just confused and you go off on the tangent, and it's like, no, you need to really step back and understand what is going on. Okay, so, and understanding what is going on first and foremost means know the rules. You don't just sit down and just play chess by randomly moving pieces around the board. They have to move in a certain way, right? The knight moves in an L, right? One guy over, two guys forward, or one guy over, two guys down. You're not allowed to move two over and then one and then three up, right? It's not in the rules. And it's like, oh, chess is so hard, it's not fair. You know, it's not, that's not, you're not following the rules. That's why it's hard. I get that the knight moves in an L shape, but I don't understand why I can't move from here to here, because that's not the right L shape. The L shape is a very specific L shape. You elongated one part too much, so it's not going to work, right? So that's what I want you guys to understand. It's not okay to kind of know it moves in an L. It's not, no, it moves in an L where the long part is 3 squares, the short part is 2 squares, and only that kind of L. Any other kind of L, it's not going to work, right? So that's the kind of level that I want you to think. So this is, in some sense, the most basic level of thinking when it comes to actually working through a mathematical problem, but it's actually the part, because it's most basic, it's the part that most people overlook and they get in trouble like that. So I just want to make sure that that's down. Now, I've elaborated a lot on this, but I really wanted to kind of do a case study or something where we can actually see how we're applying the rules. And I guess I'll try to move a little quicker. So that was the answer here, x squared over 5, x squared over y to the 5th. And like I said, many ways to skin a cat. So we could have done this a bunch of other ways. Now, I did this way because that's what Sarah saw first. She saw, oh, I remember this rule. So work with whatever you remember. Just make sure you're remembering it correctly and you know that you can apply it to the situation that you're looking at. So you didn't have to think of this rule first. So this circle labeling here is just arbitrary. You don't have to think of it first. There are many ways you could have done this. So let's look at maybe another way, just for fun. We had e to the ln of x squared minus 5 ln of y. Yeah, right? So tons of ways you could have seen this. You could have seen, oh, there's a rule, a law of exponents, that when subtraction is in the power, it means division. You could have seen that first, and it would have been okay, and you would have written it like this, and that's totally fine. And then you'd be like, oh, I see that this is going to cancel here and give me an x squared, and whoop, can't cancel that. Why? Because the 5 is in front. So now I have to take an extra step and move that 5 up. Now I can cancel. Right? And you get the answer again, right? Same correct answer, totally different approach, depending on what was seen. Or like I said, tons of ways to do this. You could have first realize that this is ln of x squared times, if you look at it like that, because there's a rule that says if you have two things of the same base and you multiply them, you add the powers, then you could realize that, oh, I can cancel this and get an x squared. And then you go and you try to cancel this and like, illegal. Why? Because there's a in fact, because there's a minus 5 in front. So what you can do is, oh, I'll use the rule that allows me to bring that minus 5 up. Now I can cancel that. And of course, if I rewrite this so that there are only positive powers, which there's no real reason to do, just to show you that it's the same as last one, you'll get the same answer. Okay. So very important lessons here. Hopefully that's kind of clear. So tons of ways you can do it. Go with what you see first, because you'll do faster and do better if you kind of go with where your brain naturally goes anyway. You don't want to fight against your own brain and force yourself to do something in a way that feels unnatural. But at the same time, whatever your inkling is, make sure you're going down that path correctly. So tons of ways, but the devil is in the details. Yeah, let's get through the rest of this. Okay, let's look at this, expand and simplify. We actually had a guess for this one. I think Sarah guessed it. Half ln of blah, blah, blah. Okay, let's see. It was a good first guess. So far, it's not incorrect. So at least it's not wrong. However, it's not fully simplified, which means you could go further here. So, however, what you did so far was very good because you did something that a lot of students would have forgotten to do. So I'm very happy about that. But let me mention that ln of what you did was you thought of this instead of as a radical, you thought of it as a half power. And then you brought that half power down in front. Yeah. Square brackets here. And then you're like, okay, I have log of a division. That means I can change these to subtractions, which you can. So this is ln of x squared minus 1 minus ln of x times x plus 3 cubed. Now, a lot of students would have written that, and that is incorrect. But you remember that there was a half supposed to be here, and why that half is there is because all students who paid attention to lecture 0 would remember that a parenthesis should be here. Remember from rule 4, be careful with your parentheses. You need parentheses here. That 1/2 needs to be distributed, and you can distribute it if you want. For now, I'm not going to do that though. I'll do that later. So if you distribute it, that's what we got as a guess earlier. So far it's not wrong, but we can actually do further. Because if you look at each of these logarithms, you'll realize that I can actually break those down a little more. Right? So for example, this one here has a multiplication. It's log of a multiplication here, which means I can break that into a sum. Remember in my parentheses, I know it's actually going to, the negative sign will distribute. And it would look like that. Realize that I can even go simpler. Here I have a third power. Right now, since we're simplifying, I'd rather not have to cube anything. I'd rather multiply by a 3. So I can move that down. And that's even simpler, right? Now, this would be a very good first answer, in fact. So, I mean, let's say I gave you 5 points to do this problem. If you got to where Sarah got with her first guess, I would have probably given you around 2 or 3 points. 3 points if I happened to feel very generous that day, but probably 2 points, 2.5 roughly. If you got to this point where I just left it, you would have gotten around 4 points. Does anyone see what I could do to actually simplify this further? Because I can break that down even farther. Does anyone see how?
Would you factor out the x squared minus 1?
X squared minus 1 seems very familiar, right? X squared minus 1, what's that?
It's the difference of 2 perfect squares.
Right, it's the difference of squares, which means this guy I can think of as x minus 1, x plus 1, right? Which should be a knee-jerk reaction to do that. It's not always the thing you want to do, but here, like once you see x squared minus 1, you should be thinking x minus 1 times x plus 1. Now, writing it as a factor is very convenient in a logarithm because the logarithm will allow you to break up the factors. So this would actually become and now you have a bunch of expanded logs in their simplest form possible. No one has a power, nothing is more complicated than it needs to be. I have logs of a bunch of linear functions. And I could distribute the 1/2 at this point if I wanted to, but it's not necessary. So I'd actually stop there. So knowing how to expand logs is very important. In fact, this kind of procedure, you should know expanding logs is useful for doing calculus computations. So if this is a problem that you wanted to do calculus on, right? So you're in calculus mode, and for some reason you want to apply a calculus operation, which we will talk about. We haven't started talking about calculus yet. Rather than apply the calculus rule to this thing as is, you will have a much easier life. It's not that you can't, you can, but you will have a much easier life if you first rewrote that as this and then did calculus. Now, there are times when the opposite is true. You will notice that there was a problem where I asked you to actually contract something. So sometimes I had the logs spread out, but I actually wanted to combine them, right? And that's useful too, but for a different reason. So you need to know what the goal is and what you're actually trying to accomplish. And yeah, someone caught me slipping here. Probably should have been more specific and said combine and simplify. Because I mean, just having an x times something over an x, it's kind of weird to just leave it like that. You would have just canceled. So yeah, there are actually tons of ways to do this one. Probably one of the nicest ways is to just, for that middle term, just bring the 3 down. And now just realize that your log to the base 2 of x is like a common term. It's like I have 1 apple minus 3 apples plus 4 apples, right? So how many apples do I have left? Well, 2 apples, of course. And that's the answer. You could have, which I suspect is what the student did. I think it was Anya, I don't remember who said it, was to apply the rules that actually brought the power, combine the logs. So what she did was to bring the power, the 4, instead of bringing the middle thing's power down, she brought the last thing's power up. Then she started combining the logarithms. So log of x minus log of x cubed, well, that gives you a log of a division. And then when you have a sum of logs, that gives you a log of a multiplication. So I believe that's how it was left, which is not wrong, but again, it's not going as far as you could, because you can actually simplify things here, right? So this goes into that, and you'd be left with 1. So you'd essentially have log to the base 2 of x squared, which we know we're allowed to bring the power down from that. Right? And you can get the same thing that way. Now, so this is the opposite of the last problem. So the last problem, we had 1 log, 1 big log, and we split it up into a bunch of baby logs. Here we have a bunch of little logs, and we actually combined them into 1 log. The log didn't end up being big because of all the simplification happened. But the point is I went from a bunch of logs to 1 log versus going from 1 log to a bunch of logs, right? Now, why would you do this second thing? Now, it's combining logs. Is useful for solving equations. Right, so if your goals are more algebra focused, you want to say x equals blah, right? You want to solve an equation for x, and you have a bunch of logs in that equation. What you want to do is you want to combine the logs. Combining logs will actually make it easier to solve the equation. Whenever you have to do something with calculus, so you don't want to find x, you want to actually do something to the function to apply some calculus concept, it's easier to spread out the logs. So you should know when you should be doing what, okay? So combining logs is useful for solving equations and doing algebra manipulations, pre-calc and algebra stuff. Spreading logs out is useful for doing calculus stuff. So you need to know both. Because you'll be doing both of those things in this class. Problem 4. Solve for x. Okay. Now, I mentioned last time laws 8 and 9 of the log rules that I gave you guys showed you that the log and exponential functions were inverses of each other, which means computationally you can use them to cancel each other in an algebraic sense. And so whenever you see something like this, that's what you want to do. If you want to solve for x, the x is stuck inside of an exponential. I want to get rid of that exponential so I can solve for the x. How do you get rid of an exponential? With logarithms. What log should you use? It turns out you can use a bunch of logs, different kind of logs. However, a lot of the times it will be useful to use the log to the same base as the thing that you're looking at. So for example, here the base is e. Log to the base e would probably be the most appropriate log. So that's what I would do. I would throw both sides into an ln. Right? Because I know the ln is a one-to-one function. If I know a equals b, then it means that ln of a equals ln of b, right? And vice versa. Right? If they're equal, then the log of them will be equal. Right? It's log of the same thing. It all actually goes in reverse, and that's what says a logarithm is a one-to-one function. If you started out with ln of e to the x equals ln of 12, you could drop the logs and go back to e to the x equals 12. But this would be the first step. Now, this allows me to cancel the ln and the e because I have that rule, log to the base a of a to the x equals just x. And so this means that my x is ln of 12. Or you can know this directly from law 1, log law 1. Right? So in log law 1, we saw that log to the base a of b equals c is the same thing as saying a raised to the c equals b. Right? What you had was you had this side, e to the x equals 12. So it's like your a was e, your c was x, and your b is 12, which means that is going to be exactly the same as writing it the other way. Log to the base e of 12 equals x, which you know means ln of 12 equals x, right? So you could actually this follows directly from law 1. You could actually just look at this equation and just know the answer because it fits right on top of a rule. Yeah, see an exponential, I don't want it. I can use logs to cancel it. Now, like I said, you can use the log to a base to match the base that you're working with, which people tend to do in practice. In math class, though, we tend to be partial to ln. We tend to like using ln, even if it's a different base. But we'll get to that. I'm not going to do too much of that today. So for example, here, where the base is 2, I'm going to solve this using a log to the base 2, even though I could solve with an ln. Here's another one. This we could solve. Let me say this phrase. Like I said, language is important, so I want to explain some language that myself or other people would say at this point. When we see e to the x equals 12 and then we ln both sides, that's how we kind of say it, ln both sides. Technically, it's not correct to say that, but that's how people say it, right? So whenever someone does a maneuver like this, we say we log both sides. So in class, if you ever hear me say, "Oh, professor, how would you get that?" and I would say, "Oh, just log both sides," and I'll move on, right? I expect you to know what I mean when I say that. Log both sides means doing this. Throw both sides of an equation into a logarithm to cancel stuff and simplify, right? So you call that log both sides, right? Or ln both sides if you want to specify the log. You could do a similar thing here. So what I can do is realize that to cancel a log, I can use an exponential. So I can realize that this is just, it means I can put this in e to the, if ln of x is equal to ln of 9, then e to the ln of x is equal to e to the 9, right? And this is what's, again, in terms of English and math, it makes no sense to say this, but people would usually say it. So I just want you to be aware of it. It's more a colloquialism, but we would say e both sides. Or raise both sides to the 2, which is completely the wrong phrase, right? Like mathematically, it's actually raise both sides to the 2 really means squaring both sides. But for some reason, this is how we say it. Just raise both sides to the 2. Mathematically wrong. But people say it so commonly, which is why a lot of people aren't great at math. It's not because of the math, it's because they learn the language wrong and they do the wrong things because their language in their brain isn't matching up with what they're actually doing on paper. But it's just how we phrase it, e both sides. It's also worth mentioning that you do not need to write this down as a separate line. It's very uncommon. So sometimes you will see a problem like this. Someone would literally just write this down underneath the equation and then jump to the next line, right? So that would mean at this point, you'd realize the e's and the ln's cancel. And so you just get x equals e to the 9. And that's the answer. Note, log law 1 would also give you this answer. Right, in like one step. But because this kind of maneuver is very common, I want you guys to know about e both sides or log both sides. You see an exponential, you want to get rid of it, use a logarithm. You see a logarithm, you want to get rid of it, use an exponential. That's a very important concept. Just like when you're solving an equation, you see a plus sign, use a negative sign to get rid of it, right? X plus 2 equals 5. What do? Minus 2 from both sides, right? You know that whenever I see one symbol, here's the symbol that undoes that symbol, right? That's what I want you to kind of get, right? This is the trick or the method that you should have in your head. Use exponentials to get rid of logs, use logs to get rid of exponentials. Here's another one, right? I want to solve for x. There's an exponential. What do? Log both sides. I just write it in here, and then I move immediately to the next line, and I cancel that stuff in my head, and I'd write 5 minus 3x equals ln 4. So what I just did was I logged both sides, right? And what that did was now it gets rid of the base e. And now solving for x is just, it's a matter of algebra, right? I can move the ln 4 to the left side, move the 3x to the right side, and then divide both sides by 3. Right? So that's just the idea, right? I see an exponential. I don't want it there. Log, right? I see a log. I don't want it there. Exponential, right? That's the gist of what I want you guys to get here. And this is very important for, solving equations. So here's another one. Now remember what I told you. combining logarithms is very important for solving equations. So here's an equation where I have several logarithms. Have several logarithms. Want to solve an equation. Do you want to solve an equation? I watched too many commercials apparently. Want to solve an equation. Try this new product today. Then your first goal should be combine the logs. Yeah. So do you have several logs? Do you want to combine an equation? Combine them. 3 easy payments of, okay. So here, because I have several logs and I know when solving equations, Jhevon told me combining the logs makes sense. That's what I would do. I would work on getting these into a position where I can combine the logs. How can I do that?
Would you bring log of x to the other side and add
Yeah.
it?
Yeah, now what?
Now in case the law that says you have 2 logs being added, it's now like multiplication.
Okay, and so you would have x times 2x plus 1 equals 2, right? So now you've combined all the logs. Now what? I want to solve for x. How do I do it?
Would you distribute the x? Or wait, no, you can't.
I mean, you mean inside the logarithm?
Inside the logarithm, because then you'll have like x squared plus x.
Okay. Nothing wrong with that, but it doesn't really take me out of the position I'm in. Okay, but not necessary at this point. I mean, I'm still in the same position, right? My x is stuck inside a logarithm. The thing I want to solve for is inside the ln, right? The x is what I want. So you doing this move, while technically it's not wrong, it doesn't get you any closer to the goal. My goal is to get the x.
So you do e to the like the log.
Right. You e both sides.
E both
right?
sides, yeah.
So you go boom, boom. Right? So that brings you down to the 2x squared plus x, and you get e squared. Right? Now, there are no logs. My x is out in the open. How do I solve this guy? I'll give you guys a hint. That would be a nice first step. How do I solve it? Ideas? Any ideas? Tell me what you're thinking. Nothing. I'm drawing blanks here. Totally drawing blanks here, dude. Yeah.
You factor it.
You're thinking factoring. Why did you do that? Because it reminds you of a quadratic equation, right?
Yeah.
Okay, so, okay. But factoring with that e squared, how are you going to do that? Like factoring when you've done it before, what did we have? We had like whole numbers, right? Where you're like, oh, I want two numbers that multiply get this and add to get that and blah, 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 right? It's kind of hard with an e squared to do that. So yeah, you're on the right track. You're definitely thinking of it as a quadratic, but factoring is not how I would go about it. So if you want to solve a quadratic equation and factoring is not an option, what do you do?
Would you use the quadratic formula?
You'd use the quadratic formula. So hopefully you remember the quadratic formula. In the quadratic formula, A would be 2, your B would be 1, and your C would be minus E squared. And then you know that your X would be minus B plus or minus the square root of B squared minus 4AC all over 2A. So applying that here, you know your X would be minus B plus or minus the square root of B squared minus 4 AC all over 2A. So that would be your answer. Where are we here? Now, of course, we have to check this. Note here that we need to ignore the minus in the middle because that would make X negative. Now that's a problem, right? If we take the X is minus 1 minus this radical all over 4, that's a negative number because it's like minus something in the top. Now, X being negative is a problem because we started out with an ln. It would make the ln undefined. So just like back in algebra class, you know, there were certain maneuvers that when you did, you had to check your final answers. This is one such maneuver, right? So you know that if you're solving an equation by raising both sides to an even power, you have to check your answers at the end. If you started out solving an equation where there were rational functions and you had x's in a denominator, you had to check your answers at the end. In the same way, when you do something like e both sides, you have to check your answers at the end because remember the exponential always returns a positive output. So once you e both sides, it kind of invalidates the negative outputs. And so you might miss answers or get an erroneous answer. That's normal. So you should be sure to check your answer in this situation. And that would end up being giving us just minus 1 plus the square root. And that would be the final answer. Same thing here. Want to solve an equation. What do? Combine the logs because I want to solve an equation. So this is log of x times x minus 3. And by the way, we got stuck here for a while. And the reason is because you guys forgot the template, right? So the template here was actually one that you had from pre-calc class. What does a quadratic look like? Ax squared plus bx plus c equals 0, right? So that's the template that you should have had in your head, right? Once you see the x squared and the x, your mind should automatically gravitate towards this template, which now notice that it's not quite right here. So I move things to make my template fit. But pretty much all math that you've ever done to this point is like that. It's all just fitting a template together, right? Now, how we figured out these templates is mathematical thinking, but at this level, you don't need to know it. You just need to be able to take what people have done and actually apply it. And it comes down to just thinking of the rules as templates. That's pretty much all it is. Every time you're in a situation, there's a template that's going to fit your situation. And that's true in math for a while. Most people never get to a math class where that stops being true. So you guys, chances are you guys are good with doing that. If you know that, you're good at math pretty much. Eventually math gets harder than that, but that's for other majors to worry about usually. Yeah, so that here I have a log. I don't want the log. I want to solve for x. What do? Exponentiate both sides. This case, I'm going to use base 10 because I have log without any base written, which means base 10. We looked at that last time. So that means the log is going to cancel here. And on that side, I would have 10 to the 1 power. Then we try to figure out how do I solve this. At this point, the quadratic template is still in my head. So I know that, oh, this is x squared minus 3x equals 10. Or in other words, this is x squared minus 3x minus 10 equals 0. And here, these are whole numbers, so I try to factor. Two numbers when multiplied give me minus 10, add them gets me minus 3. I think a minus 5 and a plus 2 would work. So this means that my x equals 5 or my x equals minus 2. Now I'm going to check, does that actually make sense? X equal minus 2 is bad. Reject. Why am I going to reject? It makes the log of x minus 2, which I had in x minus 3, undefined. So I'm not allowed to actually pick that value. However, if I pick the x to the 5, you will notice that if I go to the original, I would have log 5 plus log of 5 minus 3 on the left side. So this is log 5 plus log 2. This is log of 5 times 2. This is log of 10, which is 1. And if I look at the other side, it is a 1. So the x, so this one solves it. And so that's my answer, x equals 5. And the last one before I let you go. So I also wanted to talk about average rate of change today, but of course we're not getting to it. But it's very important that I had to slow things down to make sure that we get this, because it'll cause a lot of problems in the future if we don't know these little things. So want to make sure that we're all on the same page. So we'll speed up to get faster later, but hopefully by that you have all the basics down, so it will it'll be good. But the next thing I want to talk about is average rate of change, and then we'll actually discuss a little bit about what calculus is all about, and then we'll actually start calculus the next class. So yeah, exciting stuff on the horizon. So we actually start calculus this week, but we need the basics because just because we were calculus doesn't mean our algebra is not important. So here I want to solve for x. There's a base 2. Don't want the base 2. How do I get rid of the base 2? Log both sides. log to the base 2 because the base is 2. So that just gives me x squared plus 1 on this side. And I get log to the base 2 of 5 on that side. Don't freak out. That's just a constant. Right? It's a number. There are no x's in it. So I can actually solve for x. So this is log base 2 of 5 minus 1, where the minus 1 is separate. And then I can just say my x is equal to the square root, plus or minus log base 2 of 5 minus 1. Now, whether my x is positive or negative does not matter because I'm squaring it in the original. So that answer should be fine. However, of course, it's a square root. So you should be concerned. Does this actually make sense? Would log base 2 of 5 minus 1 be negative? It turns out no, because log base 2 of 5 is actually bigger than log base 2 of 4 because the log moves up. So at 5, it's actually higher than it was at 4. And log base 2 of 4 is 2. So this means that my log to the base 2 of 5 minus 1 is actually going to be bigger than 2 minus 1, which is 1. So what's under this logarithm is going to be bigger than 1 for sure. So positive, and we don't have to worry about. So x being negative or positive is fine, as well as what's under the radical is still good. So we'll stop there for today. Still doing basically algebra stuff, but I was dropping some very important lessons. Hopefully you guys are paying attention as to how you want to approach these problems. At the end of the day, there's always a template. If you're confused, you're stuck, what it means is there's some formula that I gave you that you didn't memorize yet, and you don't know it well enough to see how to fit it as a template on top of something. So work on that. Next time we'll talk about average rate of change and calculus, and we will start calculus. So I would probably look over average rate of change if I were you guys to make next class go by okay. That being said, we are going to wrap up. Any final questions before we go? Okay, seems fine. And I mentioned that I would send out more notifications to make sure everyone's getting emails. I totally forgot. I'm going to do that right now. So right after this, look out for emails from me from my email, but I think everyone got that. So also Jupyter, Gradescope, and Blackboard. Okay. With that being said, I will let you guys go. See you guys in the next one.